A common question that we're often asked is, how accurate are altimeters? We have a variety of altimeters that we sell here at Apogee Components, like the new Altimeter 1, the How High, and the Perfect Flight 15K. But people always want to know, when the altimeter reads, like this one here reads 1,118 feet, is it actually 1,118 feet? Well, the short answer is I can't answer that question, because I don't know how accurate they are, because it's the way how altimeters work. Now, all these are barometric altimeters. That means that they measure the pressure of the air. Let me give you a little demonstration. So air is made up of individual molecules that are just randomly bonking into each other. And the pressure sensor is kind of like this table. So every time a ball hits the table, it exerts a little bit of pressure on that sensor. Now, the sensors are very small, like you can see here on the Perfect Flight one. It's this very tiny sensor, and it's got a very small pinhole in it. And the air actually has to go into that pinhole and touch the table that's inside. And that's how it measures the pressure. It measures how many times the molecules are bonking into it. Now, air is pretty random. Sometimes you get a gust of wind and it's pushing all these, and it's bunching them up and it's pushing them all away. And when it hits that pressure sensor, it senses the air hitting it harder. Now first, let me go back a step here. Now when we're measuring pressure, what we're doing is we're comparing the pressure on the ground versus the pressure in the sky. The higher you go, the less air there is, right? So that means there's less chance of these balls bonking into it. And when you get all the way into space, there's no air pressure. It's a vacuum. So there is actually a formula that calculates how many molecules of air there should be at any altitude. And this is called the atmospheric lapse rate. And if you go to like Wikipedia and type that in there, you'll find the formula for this. And it's a pretty involved formula, because it not only depends on the altitude, but it also depends on the pressure, the temperature. You know, high temperature, what do we mean by temperature? Temperature is the motion of these particles. So the faster they move around, the higher the temperature. And when they're moving around, they're bonking into each other and they're stretching out. And so the higher the temperature, the less pressure you're going to sense. On colder days, these molecules are going to bunch up a little bit more because they're not moving around as fast. They're not hitting each other and pushing each other away. So on colder days, you're going to have more pressure. And so so one of the things is pressure, or a temperature, and another one is humidity. When there's a lot of water molecules in the air. Now, water molecules are bigger than just regular air molecules, like an oxygen molecule. You got two hydrogens and an oxygen, so they're a bigger molecule, so they're going to take up more room. So you have all these other variables also in there that affect how the pressure that these sensors are going to detect. Now, basically, all the sensors are pretty accurate. You know, with modern technology, what these can sense is pretty minute. They can sense the difference between, 1 foot. They can even sense that. But even though that they can sense it, the air, the pressure in the air, because there's air currents moving around constantly, mixing up all these balls, what these actually sense is going to be different, because the amount of air going past it is going to be different. So it's very hard to say with exact certainty that when this says 1,118 feet, it's actually going to be 1,118 feet. And all these altimeters, they work a little bit different. Remember that equation? Well, these altimeters, like this one here has a thermometer on board, so it senses the temperature, but it's not sensing the humidity. So each one works a little bit different. So that equation, that lapse rate equation, is a little different in each altimeter. For what the altimeter does, it's pretty good, but you can't compare an apple to an orange. You can compare two apples. So this one here sensed 1,119 feet, but it didn't sense, and this one was 1,118 feet. So there is a little bit of a difference. Now, even 1 foot difference is going to be hard to detect. If you zero this out and set it on the floor, and then you put it above your head, and now you're about 18 or 8 feet above the floor, you would expect it to read 8 feet, but it's not. You know, that's just because the air currents are constantly moving around, and it's got to go into the little hole. And on this one, the little hole is on the bottom here, so the air has got to go in there and actually hit the diaphragm, and for that to actually measure. So, like we said, one of the most important things on your rocket is the air holes. Wherever you put your altimeter, you have to put an air hole so that the altimeter can breathe. So make sure you do that and follow the recommendations of the manufacturer for whatever altimeter you're using. Now, the Perfect Flight, it's a recording altimeter, so it's a little bit different. It needs to record pressure constantly, where these are just peak altitude, so they don't need to record nearly as often. And in fact, one of the nice things about these is that as the rocket's going up, it's slowing down, and that's when it's taking its reading. When it's going nice and slow, it's when the air is moving more constant than when it's moving really fast when the rocket takes off. So when the rocket takes off and you want to measure that, then you need a recording altimeter. And then it's even more important where these holes are placed on the rocket, because as the rocket goes up, the pressure inside the rocket is actually greater than the outside pressure, because like we said, when you go higher, the pressure decreases. So the air actually has to come out of the holes as the rocket's taking off. But where they're located on the rocket is important. They really need to be at least 4 body tube diameters below the base of the nose cone. That's for a recording altimeter. Now, for a peak altitude altimeter like the Altimeter 1, it's not nearly as critical where that hole is. As long as the air is getting out, you're okay, because as it slows down, the air has a chance to get out, and for this to actually measure the altitude of the rocket. So I hope that gave you a little bit of an idea of how accurate altimeters are. They are pretty good. You know, people have been relying on barometric altimeters for a long time. They've been used in airlines for decades, since probably the 1930s, and they are pretty good. But how accurate? You know, is it 1 foot difference? Can it measure that amount? Probably not, because the air is not perfect. The sensor is pretty good, but the air is not perfect. So don't expect to be able to compare altimeters to see which one's more accurate. It's not going to work that way. Now you can compare 2 altimeters and see how they compare. But even then, the air is going to be different. Like, let me show you a little experiment that I like doing with these altimeter ones. First, I'm going to zero them out. I'll just press and hold until I get 4 zeros. And then I'm just going to put them in my hands and suck the air out of my hands. And then I can measure how high these altimeters are. So this one read 2,759 feet. This one read 2,755 feet. A difference of 4 feet. Well, one altimeter was closer to my mouth than the other one, so it felt a little bit less pressure than the other one. So that's pretty good. So you can compare 2 altimeters of the same type, and this is why TARC, when they run their contest, that they have everybody use the same brand of altimeters so that all the equations inside are the same, so everybody has an equal chance. So that's altimeters. And if you have any questions, please send us an email. Our web address is www.apogeerockets.com. My name is Tim Van Milligan. May the winds be light, may the skies be blue, and may all your rockets fly straight and true.